Man, my chest is tight. I can barely breathe. I'm wheezing a lot. I don't know what's wrong. I really need to go to push. Looks like I'm in here.
Hi, Matt.
Hi, Doc. Nice to meet you.
Have a seat. Tell me, what seems to be the problem?
Well, Doc, I was on my way to thermal class this morning and I was running a bit late, so I had to run to class. I stopped myself at the entrance of Forney because I was wheezing a lot. My lungs were killing me. I think something's wrong.
You think so? Take a deep breath for me. I'm sorry, Matt, but I think you have asthma.
Asthma? What's asthma?
Hi Kim262, we're Team 12. Our Real Life Orgo project is over albuterol sulfate. Our topic was inspired by Stephanie's use of a rescue inhaler that contained albuterol sulfate to help treat her asthma. In addition, Matt and I are both in sports here at Purdue and experience others using albuterol sulfate every day at practice. In this presentation, we go over what albuterol sulfate is, what it's used for, differences in albuterol sulfate and other chemicals in the body, and how the body processes it. I'm Casey Hilton and I'm doing the voiceover. My other teammates, Stephanie Wiseman, Fernando Escribans, and Matt Schraders, did the acting in the videos that you saw earlier and will see later. We worked together to edit the videos, create the slideshow, and research our topic and bring you the presentation that you are about to see. In order to understand albuterol sulfate, the first thing we must ask ourselves is what is asthma? Asthma is a condition when the airway muscles tighten and become filled with mucus. The visual at the bottom right shows what is happening in airways as a person undergoes an asthma attack. The leftmost airway is a normal person's airway. The middle one is someone who has asthma before an asthma attack. As you can tell, the asthmatic airway is already smaller than a normal one even though it is not yet inflamed by an attack. The rightmost airway is an asthmatic airway during an asthma attack. You can see the mucus buildup and tightened muscles which indicate the attack. A person can be born with asthma or develop it as they mature. Asthma is not always apparent in a person until an asthma attack ensues. Asthma attacks are often caused by exercise and allergens, but can be caused by many other things as well. Symptoms include wheezing, coughing, shortness of breath, and sometimes require immediate medical attention. The treatment of asthma are bronchodilators, which, as the name suggests, dilates or opens and relaxes the bronchi, the small airways in your lungs. Bronchodilators are explained in more depth on the next slide. Bronchodilators are molecules that trigger the beta-2 receptors in your lungs. Beta-2 receptors are hormone and neurotransmitters that signal muscle relaxation and specifically bronchodilation. Adrenaline is a naturally produced bronchodilator and will fit in the beta-2 receptor and begin the bronchodilation process. However, since it's a natural compound found in your body, the body has ways of clearing it out and recycling it quickly. Adrenaline decomposes through methylation before it can significantly reduce any inflammation in the airways. Scientists cleverly created new bronchodilators that mimic adrenaline and that they still trigger beta-2 receptors in the lungs, but don't decompose as quickly as adrenaline, since the methylation takes much longer to occur. The medication in rescue inhalers will decompose after about 2 hours, which is long enough for the bronchi to relax to a normal state. The most common bronchodilator in asthma medication is albuterol sulfate. Albuterol sulfate, also known as salbutamol, is found in rescue inhalers such as Proventil and Ventolin. Albuterol sulfate is best used as a gas, but can also be produced as a liquid medication. Bronchodilators in you. Again, bronchodilators trigger the beta-2 receptors in your body, which are found in your airways in your lungs. Your body's natural reaction to albuterol sulfate is to reduce inflammation in the lungs, relax the surrounding muscles, and to clear the mucus in those air passages, which helps with an asthma attack by clearing up the lungs in order to help a person breathe regularly again. The immediate side effects of the body responding to a bronchodilator are similar to that of adrenaline, and it can include jitters, shaky hands, and increased heart rate. Although these side effects are immediate, they don't last very long. Adrenaline versus salbutamol. The first thing to note is how similar adrenaline and salbutamol are. Not only are their purposes the same, but their structures are similar as well. Adrenaline is naturally produced in the body to dilate the bronchi, while albuterol sulfate is not naturally produced in the body. Salbutamol is different from adrenaline in these two major ways. The metaposition alcohol is put further away to slow down the methylation. On both molecules, the methylation occurs at the metaposition alcohol, and by putting this alcohol further away from the ring, as done in salbutamol, as you can see on the right, it methylizes slower than adrenaline would. Secondly, the T-butyl group on the nitrogen helps the beta-2 selectivity of the salbutamol. This group helps the salbutamol go directly to the receptor, instead of bouncing around and stimulating other receptors like the adrenaline can. With these two changes, the salbutamol is much more effective because it will go directly to the correct receptor and stay there much longer, allowing the effects of the bronchodilation process to last longer. Finally, methylation. Methylation is a process that causes the adrenaline to be kicked out of the beta-2 receptor. The inventors of albuterol sulfate wanted the same effects of adrenaline, but over a longer period of time. They figured out how to do this by slowing down the methylation of the compound. This was achieved by the addition of a carbon between the ring and the alcohol, which makes the alcohol sit further away from the ring and makes the methylation take longer. The methylation of both adrenaline and salbutamol occurs by SN2 nucleophilic substitution. This is also called electrophilic methylation. Through our research on methylation, it is probable that adrenaline is easier to methylize because it is a more effective and stronger inductive effects that draws the electrons closer to the oxygen, thus making it more susceptible to methylation. You can tell from the models at the bottom of the slide that the oxygen on the model for adrenaline is closer to the ring than the oxygen on the salbutamol model, and since the oxygen is further away, its inductive effect is less intense. More resonance structures can show the possible reactivity of the adrenaline and salbutamol, further explaining potential reasons why salbutamol methylizes slower than adrenaline does in the body. Additionally, another argument for why salbutamol methylizes slower than adrenaline is that the delta H for the salbutamol is higher than that of the adrenaline. Now, this is a lot of technical descriptions and words, but to help you better understand how methylation really works, here's another video made by my teammates.
What's up? I'm adrenaline. Oh dang, that's a nice beta-2 receptor. Oh yeah, I like that. I like that. Oh, there's a lot of inflammation though. Let's just get all up in here. Ooh, let's get rid of some of this inflammation. Oh.
Hold on. I'm methylization. And I'm gonna methylize you.
Ah!
So you no longer fit in this beta-2 receptor before you can do any reduction of inflammation.
What's up? I'm Albuterol Sulfate. Hey beta-2 receptor, that adrenaline didn't do a very good job, did he? Yeah, that's right. You need a real bronchodilator to take care of you. Let me just take care of some of this inflammation for you.
Hold up. I'm methylation.
Whoa,
Wait.
back off. I'm not
Hold
done.
on.
I'm not done here yet. Hold on.
I need to methylize you.
Skirt. No.
Almost done.
This is all for you, bronchial tubes.
Alright, you've been mephilized.
Oh,
Time to
man.
go.
It was fun while it lasted.
The main concepts covered in our presentation are what asthma is and how it affects a person, bronchodilators and how they work in the body, the acceptance of the medicine in the body's beta-2 receptors, and our arguments for the process of methylation, which include nucleophilic substitution and inductive effects of the albuterol sulfate in the body. These all explain why albuterol sulfate is such a commonly used medicine for treating asthma.
So everything we learned today is in this rescue inhaler. Keep it on you wherever you go.
Wowzers. That's incredible, Doc. Thanks so much for everything.
Anytime.